So these are the questions from block 1, from topic 1.1 till topic 1.8. You can use my chat. You can also annotate on the screen to answer these questions. The mass of air passing through a circular area swept out by the turbine blades in each second, like in 1 second, is 7.5 kg. The kinetic energy of the air that passes through this circular area is 240 joules in each second. Calculate the speed. So kinetic energy is half mv square. Then we have the kinetic energy, which is 240 joules. Half the mass is 7.5, and then v square. This 2 is divided, other side it will be multiplied. So 240 multiplied by 2 divided by 7.5. And then take a root because we need v. So we take a root. So 240 times 2 divided by 7.5 in a root. So 8 meter per second. Always write the units. So 8 meter per second. The kinetic energy of air drives the generator. State the input power. Look, this is the energy, but because it is in 1 second, so we have the formula power is energy divided by time. So the kinetic energy, because like what actually happened, the air is moving. So moving air will have a kinetic energy and it rotates the turbine. So how much energy it supplied? 240 joules. And in how much time? 1 second. So if we need the power, we have the power is energy divided by time. So energy is 240 and time is 1. So 240 divided by 1. So we get 240 and the unit will be watts. So whenever like time is 1 second, they have the like energy and the power is same. The magnitude is same. The units will be different. Next is we need the output power. So the output current is 2 amperes and the potential difference. So if we need the power, we have the formula P equals VI. Always write the formula. So it will be 11 multiplied by 2, 22 watts. Then we need the efficiency. What about the efficiency? Efficiency can be in terms of power. It can be in terms of energy as well. So in this case, the input power, like efficiency is a useful power input. Useful power output divided by total power input multiplied by 100. So how much is a useful power? That was 22. And what was the total power input? 240 and multiplied by 100. So the efficiency of this turbine is 9.2%. Because it is taking the kinetic energy of air and converting into electrical energy. The density of air is 1.3 kilogram per meter cube. Calculate the volume of air passes through a circular area swept out by the turbine in each second. So how to work out? You have the density is there and the mass is also given in the beginning of question. Like in 1 second, the mass was 7.5 kg. So density is mass over volume. If we need the volume, it will be mass divided by density. So mass is 7.5 and the density is 1.3. So it will be 5.33 and the unit will be meter cube. It was 5.8, I guess. 5.77, not 5.33. So it was rounded off. The next question related to topic mass, weight, and density. Figure 1.1 shows a piece of a glass which is 2 centimeter thick and 0.15 meter area. The density of a glass, calculate the weight. So if you want to calculate the weight, weight is mass multiplied by gravity. We know the gravity 9.8. So first we need the mass. How to work out the mass? We have the density, but the unit of a density is kilogram per meter cube. So if a density is mass over volume, so mass will be density times volume. We have the density which is 2.6 exponent 3. But what about the volume? The volume is area multiplied by height, but area is meter square and the height or the thickness is in centimeter. So we have to convert this into meters first. So divided by 100, so it will be 0.02 and area is 0.15. So when we multiply them, first we get the mass. So 0.02 multiplied by 0.15 multiplied by 2.6 exponent 3. What is the answer for this? 0.02 times, so 7.8. Gravity, yeah, if we have to take, okay, 7.8 and then the gravity, the mass is 7.8 and then to get the weight, you have to multiply it by gravity, so you have to take 9.8. Because this is from old past paper, so the marking scheme answer is related to gravity 10, but as you, for a practice, take 9.8. A piece of a glass shown in figure 1.1 is used in a vertical viewing window in aquarium. So example, this glass is there. The atmospheric pressure from the outside is 1 exponent 5. The average pressure from inside is 1.3 exponent 5. Calculate the resultant force acting due to this pressure and state the direction of the force. So example, if this is representing this aquarium, like it's representing a water inside, it is exerting a pressure from inside. Is 1.3 into 10 to the power 5. And from outside, the atmospheric pressure is there, which is 1 into 10 to the power 5. We need the force and its direction. So first, because the two pressures are in opposite directions, so we subtract. So it will be 1.3 into 10 to the power 5 Pascal minus 1.0 into 10 to the power 5. This will give us the resultant pressure, which is about 0.3. After getting a resultant pressure, we need the force. We have the formula, pressure is force over area. So if we need the force, pressure times area will give us the force. So 0.3 into 10 to the power 5 multiplied by area, the cross-sectional area of this glass is given in the beginning 0.15. So that is 0.15. So we multiplied this by 0.15. So we get the force, which is 4,500 newtons, and the direction of the force, because out inside, so it will be outward, or yeah, outwards, because the outside pressure is more than the inside pressure. The next is figure 1.2 shows a vacuum pump connected to the top of a vertical tube with its lower end immersed in a tank. The pump reduces the pressure above the column to 0. Like here, the pressure from this side is 0. Yeah, sure, I will re-explain. See, you in the question, you have this glass is used in aquarium. Two pressures are there. This glass is used in aquarium vertically. Example, so you have the water here. The pressure exerted by the water is 1.3 into 10 to the power 5. And the pressure exerted by the atmosphere from outside is 1 into 10 to the power 5 Pascal. So how much is the difference in the pressure? The difference in the pressure will be 0.3 into 10 to the power 5 Pascal, which is outward. The question is not calculate the pressure. The question is calculate the force. We have the cross-sectional area, which is given 0.15 meters square. So if you want the force, force is pressure, which is 0.3 into 10 to the power 5 multiplied by 0.15. That is the cross-sectional area. That is 4,500 Newton. And because the outside, the pressure from the water outward is more than the inward, so what is the resultant force? So resultant force will be outward. The next figure 1.2 shows the vacuum. The pump reduces the pressure, and the pressure at X is, so here at this point, there is no pressure because it's a vacuum. So here 0 Pascal. And at point X, how much is the pressure? 9.6 exponent 4. And that is only the pressure due to the depth. And the depth is 12 meter. We need the density. So we get pressure is equals to density, gravity, and depth. The pressure is 9.6 into 10 to the power 4. Depth is 12. Density we don't know. And a gravity will take 9.8. So this factor is multiplied. Other side will be divided. So 9.6 exponent 4 divided by 12 into 9.8. This will give us the density, which is 816, and the unit kilo. Whenever you write your answer, the final answer should be in 3 significant figure. So if it is 816.3, we'll just write 816, and the unit will be kilogram per meter cube. Keep one thing in mind: whenever you're substituting the depth, like the length, it should always be in meter. Some questions, this depth is in centimeters, so don't forget to convert into meters. Otherwise, the base unit will be wrong. The next question is related to topic moment. State what is meant by the term moment of force about a pivot. So turning effect of the force, or you can also say product of force in perpendicular distance, or you can also write a formula that moment is force multiplied by perpendicular distance. So force multiplied by the perpendicular distance, that is the formula you can write, or you can say moment of a force means the turning effect of the force about a pivot. Figure 2.1 shows a large crane on a construction site lift a block of a mass 14,000 kg. The counterweight is there. Calculate the moment about 8 due to the 14,000 suspended from B. When they say about A, so this point is a pivot. So A is a pivot for us. We want to calculate the turning effect of this block. So how to calculate a turning effect? Moment is force multiplied by perpendicular distance. So how much is a force? This is a mass. So force is the weight is a force, not mass. So it will be 14,000 multiplied by 9.8, which 9.8 or 9.81, which is the weight. Because in this case, the weight cause a turning effect, and multiplied by distance from the pivot, which is 20. So 14,000 into 9.8 multiplied by 20. So 274,400 Newton meter. But because it's a large value, whenever it's a large value, better convert into exponent. So it will be 2.7. Where I get 9.8, because we are calculating a moment. Moment is a product of force, and the mass is 14,000 kilogram. But what about the weight? Weight is 14,000 multiplied by 9.8. Because weight is mass multiplied by gravity. Weight is the force, mass is not the force. So you have to take weight, not the mass. So it will be 2.74 into 10 to the power 6 Newton meter. Then speed is a scalar quantity and velocity is a vector quantity. State the difference between a scalar and a vector. So vector is having a direction and scalar does not have a direction. Write down one other scalar and other vector quantity. So temperature scalar, length scalar, time scalar, mass scalar, force vector, acceleration vector, weight is vector, momentum is a vector, impulse vector. Pressure is not a vector, pressure is a scalar quantity. Like it does not follow the rule. Figure 2.2 shows the forces acting at an angle of a 60. Draw a scale diagram. Look, as I mentioned, now according to like the update, only vectors which are 90-degree or perpendicular, that will come in exam, not the angular vector. Means this type of a question will come in exam, but with the angle 90 between them. If the two, because we will use a Pythagoras theorem to work out the resultant, or we can also use a scale diagram. So if I modify this question, I will just change question according to our syllabus. So example, say this angle is 90. And the question was find the resultant. By scale diagram, or you can use a Pythagoras. They don't say use, they say mention use calculation method. So it's making 90. Now, how to use a scale diagram? So whenever you use a scale diagram, first you have to scale. Because you don't have a 20 or 30 Newton ruler, you have to scale. And it should be appropriate. It should not be too small. Or example, if I select, say 10 Newton is equals to 1 centimeter. So 20 Newton will be 2 centimeter. 2 centimeter line, so small, it will have a higher uncertainty. So it's not an appropriate scale. So I can select, like example, 5 Newtons. Example, I select 5 Newton is 1 centimeter. So 20 Newtons will be 4 centimeter and 30 Newtons will be 6 centimeter. Now, how to do a scale diagram? So first we'll draw, or even you're doing a Pythagoras, you should make a triangle. Even if it's an acute angles or obtuse angle, method remain the same. But because for a 90-degree, you can use both calculation and the scale diagram. So first we can draw any of the vector. It's up to you. Example, I'm drawing 30, which is 6 centimeter. So first you will draw in the same relative direction 6 centimeter. Then you will draw the second vector. From the first vector, draw the second vector, which is 20 Newton downward or equals to 4 centimeter. So we draw 4 centimeter. Now what about the resultant? Resultant is always from tail of the first to the head of the last. When we join, this will be the resultant. You can measure the length of this resultant and your answer, you will measure the length of this resultant and you will get the answer. That is one way. If you use a ratio 1:1, then it will be impossible to draw on your exam sheet. Because a 30 centimeter exam, you don't have a 30 centimeter. If I select 1 Newton is 1 centimeter, then 20 Newtons should be 20 centimeter. So it does not, it will be too large to draw on the exam sheet. So appropriate, it should not be like more than 12 and it should not be less than 3 or 2. The 30 Newton is given in the question. 30 and 20 Newtons are given in the question. The one of the vector is 30 Newton and the other vector is 20 Newton and the angle between them is 90. The original question, the angle was 60, but I changed to 90 because you will have this 90-degree only perpendicular vector resultant is there, the part. So if I want to find, so first we draw the first vector, then we draw the second, and then we measure this length. Example, say this length was 7 centimeters. So 7 centimeter means what? Because 5 Newton is 1 centimeter. So 7 centimeters, 7 multiplied by 5. So it will be equals to 35 Newton. So resultant will be 35 Newton. And angle you can measure with any of them. If they say a direction, so you can measure a direction or angle from 30 or you can measure the angle from 20. It's up to you. Any one of them you can mention. But if you use a Pythagoras theorem, then even you're using a Pythagoras theorem, you have to complete a triangle. But in Pythagoras theorem, the triangles are not to scale. Like first I draw 30 Newton because I just need the reference direction. So 30 Newton, any length I can draw. I don't need the scale. Then 20 Newton. If you start with, like example, 20 Newton first, it will not make difference to the final answer. First we example draw 20 Newtons. and then we draw 30 Newton. What will the resultant? Resultant is from tail of the first to the head of the last. That will be the resultant. And you can mark angle anywhere. You can mark angle from the top or from the bottom. Example I marked here. So with reference to this angle, here we have a base. This one is a hypotenuse and here is a perpendicular. So we use the Pythagoras theorem, the magnitude. If we need a magnitude, so it will be 20 square plus 30 square in a root. That will give us a length of the hypotenuse. 20 square plus 30 square in a root. What's the answer? 20 square plus 30 square in a root. 36. So 36. So you will write that the magnitude is 36 Newton. And if the angle or the direction you are measuring, it depends on which angle you mark on your diagram. So example, this angle we mark. So this is our base and here's a perpendicular. So to get the angle or the direction, the tangent theta is perpendicular divided by base. So tangent theta, the perpendicular for us is 20 and the base is 30. When you simplify, you have to take theta equals tan inverse 20 divided by 30. What's the answer? Tan inverse 20 divided by 30. Keep another thing in mind that theta should be in degrees here. So if your calculator mod is in radian, convert into degrees. And how to know your calculator mod is in degree? Because just put sine 90, the sine 90 in degrees should be 1. So you got 33.7 or 34. So that will be the angle with 30 Newton. Is it clear, this one? 33.7, which is the angle. So 33.7 degrees. So you can use a scale diagram. You can use a Pythagoras in exam. The vector now will be 90 degree or perpendicular. You won't have any acute angles or obtuse angles. You will have the two vectors will always be 90. Perpendicular vector resultant is the part of the syllabus. Look, in this question, the direction of a resultant relative to 20 Newton. So they asked for 20 Newton. So because as we scroll down, so we need this angle because relative to 20. So with reference to this angle, this will be our base. Here is hypotenuse and this will be perpendicular. So if with reference to 20 degrees, it will be perpendicular divided by base. So it will be 30 divided by 20. And theta equals tan inverse 30 divided by 20. You will get the answer. Or you can also do like 180 minus plus 90, like 180 minus 90 minus 33.7, you will get this angle. Because the total sum of the angles should be 90. Because in the question, the last part, as we scroll down, the question is direction of relative to 20. Like with reference to 20, how much is the what is the direction or angle they mean? In physics, the angle refers to direction. Is it clear?